position of a point, we need to write the x coordinates first and then the y coordinates.
0.
Zero. There you go. Okay,
That's simple. Oh my god.
it's quite simple, right? Yeah. Do not overthink, okay? It's easy actually. Good morning, everyone. How are you today? And before we start the lesson, I would like you to open the camera, please. Turn the camera on. Okay, let's just start the lesson today. Today's lesson will be continuing what we have previously learned last time. Okay, before we start, let's pray first. I would like Tala to lead the prayer. Okay.
Friends, before we start our lesson, let's pray in the prayer.
Okay, thank you very much, Tala. Okay, so absence Zidane hasn't come yet, but it's okay. We can just start the lesson. Before we start again, let's start by reviewing what we have learned previously and also the things that you will connect to our lesson today, which is about Cartesian diagram. Actually, it's the same question as before, guys. It's about horizontal and vertical line. In the Cartesian plane, the horizontal line is the x-axis and the vertical line is the y-axis. So is it true or false? Okay, since we have this question previously, I think you should, yes, okay. Very good, guys. Okay, next question. In a Cartesian plane, what is the coordinate? Okay, there's some of you, okay, so let's go back. Okay, guys, so remember that when we're talking about, what do you call it, the Cartesian plane, when we mention the position of a point, we need to we need to write the x coordinates first and then the y coordinates. Because we know that the x coordinates is the horizontal line. So you go here first, right? And then you go here. So it's 1, 2. Yeah? Okay, let's go to the next question. Okay, this is going up. Okay, let's go to number 3. So the learning objective for today's lesson is to arrange the general formula. So you're going to make a formula to determine the value of a gradient from 2 points on a Cartesian diagram. And then the second learning objective is comparing the values of gradients from pairs of parallel and perpendicular lines. Now I would like you to observe the line and determine the gradient. Okay, here we go. Can you determine the value of the gradient? If I just leave you like this line? How about if I gave you this? It's still the same line, but I'm adding like an x and y axis there. But I'm not giving you the grid, right? I'm not giving you any coordinates. I'm just adding those two horizontal and vertical lines.
Yes.
So what do you think is the gradient? Just guess.
0.5.
0.5? That's a nice guess, actually. Okay, but it's a little bit hard, right? What if I give you another help?
I will use the formula rise over run, which is what? 4 over 2.
But what if we don't have any grid? We just have the coordinates. Okay, if we go to the next one, if I have this guy here, it's the same thing. It's the same line, right? But this time I gave you a coordinates. So how do you think we can connect the coordinates with the value of the gradient? If I gave you like this, okay. Another question. I'm going to Kevin. Kevin, can you determine the gradient of this line if I gave you only those 2 points?
I don't know, but I
You
don't think so.
Okay. You don't think so. Okay. So yeah, okay, thank you. Okay, basically guys, this is the same thing like before, but this time we don't have any grid, right? So this is what we're going to investigate. So what is the connection between these numbers, right? This is x, this is y, and this is also x and y. How do you get that rise of run to determine the value of the gradient?
1, 1, 2, 3, 4. 4.
It's just if it's you don't have to. I mean, like if it's simple, if it is in the simplest form, you don't have to change it. Okay. 2 is just 2, right? For number 1.
Yeah. Oh, okay.
5. Y2. Y2 minus 1 minus 1. Berapa sih? Minus 2. Ya, betul.
Yang nomor 2 juga minus ya?
Nomor 2 gimana sih? Enggak lah. Enggak lah.
Oh iya.
X2
Enggak
2 minus
3 minus
5
1
minus
is
2,
2.
3.
3 minus 1 is 2. Yes, be careful.
Kok 3?
Yeah,
Oh,
5 minus 2 is 3, right? Yeah, yeah. I get it.
mati bisa 5 sih tadi.
Fine. Okay,
Eh,
good progress.
1, 2, 3, 4, 5. Ya, 5. Berapa?
It's over 5.
-1 minus 5.
Yeah, there you go. Okay, be very careful which one is positive and negative for each of the lines. Okay, remember, positive and negative. For the gradient, here
Oh,
on
yeah.
the right,
my
be
gosh.
careful.
Sorry.
Just add a
No
negative.
more.
Yeah, just add a
Minus.
negative.
Connection between the points coordinates ya, Din. Answer first.
Conclusion first before.
Ya, soalnya ini Evan already write the
Oh yeah. Okay. How about the how about the value of the gradient? I haven't seen you
haven't yet.
anything yet. Yeah.
Belum.
You can use the rise over run, yeah. The y2
The
minus
Garis,
1.
right?
All right.
I think the coordinates is okay. The
Wait,
one,
wait.
the one.
It's -1 minus 5, not
Minus
-1 minus 0.
Yes, okay. The x2 minus x1 should not be 5 minus 1. What do you think?
X2 is 5 minus 2.
Yeah, there we go. Yes, be very careful, guys. Okay, please continue and please write down also the gradient by using the concept that we have learned before.
Rise over
Rise
run.
over, okay? So what did you get? What is the connection between that?
The y2 minus y1 and x2 minus x1 are equal to the gradient.
Okay, so what do you mean equals in here?
Equal?
Yeah. So we know that the concept of a gradient is just rise over run, right? So which one's the run and which one is the rise in this case?
The
The y2 and the y2 minus y1 is the rise, and the x2 minus x1 is the run.
Okay, I would like you to rewrite that. Okay, just add a more information so that it's clear which one is the rise and which one. Can you see the pattern there?
yes.
Yes.
Yeah, you can see the pattern, right? So I'm gonna give you another hint because you know that the gradient concept is just rise over run. So which one do you think is the rise and which one do you think is the run?
The rise is y2 minus y1.
Yes, there we go. You can just write it down there, okay? So after you write this conclusion, I would like you to go back to the main room again. I'll explain a couple of things and then you go back to the second activity, okay? So let's include what we have for the first activity. Given a straight line passes through two distinct points, which is A and B, which are A and B, and where the coordinates can be denoted as this, right? You can write down the gradient as this, right? M is equals to y2 minus y1 over x2 minus x1. Oh, the y2 minus y1 is going to be the rise, right? And then the x2 minus y1, x1 is going to be the run. So we can write down rise over run if it is in a Cartesian coordinates. It's going to be m is equals to y2 minus y1 over x2 minus x1. Okay, so this is the gradient formula that we get from using the concept of rise over run. Okay, so I would like you to observe these lines from each Cartesian plane. The question is there any special connection for the position of lines for A, B, and C, D? Okay, I'm gonna give you another hint. The word is from the letter P.
Parallel.
Yes, thank you, Zidane. Yeah. Okay, this is the examples of parallel lines in real life. Okay, I'm pretty sure that you have, right? This is what we call a railroad, right? To pass for the train to pass through. And this is the real life example of parallel lines. Imagine that it's not parallel. Imagine what will the train be? I mean, like maybe it's like it can be like crashing, right?
I think it's because they cannot met. They should not met. Nggak boleh ketemu sama sekali.
Nggak boleh ketemu ya, kasihan ya.
Iya, nanti bahaya gitu kalau misalnya agak paralel tuh nggak bisa.
Okay, the point is it's going to be dangerous, right? So, okay, now let's go to the next case. I have two images, image 1 and image 2. I would like you to, previously, we know that the connection are parallel, right? How about these? So line AB and CD will have intersections, right? For both of the image, but line AB and CD from the image 2 are special because the lines makes an angle of 90 degrees, or what we call the perpendicular. So now the question is, because we're talking about straight line and we're talking about gradient, we want to know what are the connection, what is the connection between the value of the gradient if they are parallel and if they are perpendicular. Okay, so do you think there is a connection between the value of the gradient? Yet.
Dina is still counting for the.
What do you think, Dina? For line AB for image number 1, it said that the gradient is the rise over run. Okay, going from A to B, what is the rise? Is there any rise?
Zero.
It's zero, right? So the rise is zero because it doesn't go up or down, right? It's just going run. So the rise is zero. How about the run?
Zero.
Is it zero? From A to
I
B.
don't.
The
Oh,
run.
Four.
The
It's
4.
four.
So it's 0 over 4, right?
Okay.
Right? Okay, what is 0 divided by 4?
zero.
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 There we go. Okay,
That's simple. Oh my god.
it's quite simple, right?
I-
Yeah. Do not overthink, okay? It's easy actually. Boys, how about the boys? Okay, boys, yes. There is, yes, it's actually true. You have filled all of the gradient line A, B, and C. And for the boys, we'd like you to multiply that. Yeah, there we go. Right? You do the same thing with the second image and the third image. Perpendicular. I'm gonna share screen to you.
Aku nomor 2 deh.
Okay, hold on. Okay, pay close attention and be careful that it can be positive, it can be negative. Yeah, okay. Okay, means that you only need to fill that M1 times M2 for the first image. Presenter, please present it.
The result of our investigation regarding intersect perpendicular lines is that when line A's gradient gets multiplied by -1, it is equal to line B's gradient, or the other way around.
Are you sure? What did you multiply in here? It's not multiplying the gradient with -1.
Salah guys.
It's not multiplying by 1. So what do you get?
It's the gradient of line A got multiplied by gradient line B.
Yes, there we go. So the sentence should be, if you multiply the first gradient with the second gradient, then what happened?
It will be equals to -1.
Yes, there we go. I would like you to pay attention on the gradient for each pair of lines. What do you think you should do to? What do you think is the connection between the line A, B, and C in terms of the gradient?
They got switched and it's negative.
Yeah, there you go. So which means that if one is A over B, right? If the first gradient is A over B, what will be the second gradient?
Minus B over A.
There we go. Okay. Okay, so let's get to a conclusion, okay? The conclusion for activity 2, the parallel lines. Given two parallel lines where the first line has a gradient of M1 and the second line has the gradient of M2, then which means that the first gradient will be the same with the second gradient, no matter how the line is, as long as they are parallel, means that the gradient will be the same. And the second one is for perpendicular lines, right? The perpendicular means that it has a 90-degree angle formed by two of the lines. If given two perpendicular lines, again, where the first line has a gradient of M1 and the second line has a gradient of M2, which means that if M1 is A over B, then M2 is just minus B over A. Okay, but just be very careful with the minus sign, right, guys? So which means that if they're perpendicular, one is going to be minus, one is going to be positive, right? So just swap the numerator and the denominator, just that. Or we can also have another connection, because if you multiply this two gradient, then it will be equals to -1. Because we have done, is there any question or anything that you might come up with? Okay, okay, guys. So if there's no questions, thank you very much for today. And for the next session, we're going to construct a straight line equation and solving real life problem using a straight line equation. Okay, and again, thank you very much for participating today. I am very grateful to have a nice student like you guys. Thank you very much. I'll be seeing you again tomorrow. Arigatou gozaimashita. See you again. Bye bye. Thank you guys.